All right, everybody. So here's the answers to yesterday's or the problems from 2 days ago, and then I'm going to give you a couple more to try, and then we're going to start talking about substances being oxidized and reduced. Okay. So the first one was H2SO4, which is sulfuric acid. All right. If you look these up on your colorful sheet, you'll find H is +1, sulfur's -2, and oxygen's -2. And now remember, there is no battle of positivity. So the hydrogen's okay with its +1. But there is a battle of negativity, all right? And in the battle of negativity, O is greater than N. So O wins out, all right? So the S is going to change. Let's figure out what the S will be. Remember, the oxidation number is what I write on top. That's the charge of one atom. The total charge I'm going to write on the bottom. So -2 times 4 is -8, and the goal is to get to 0. Well, each hydrogen has an oxidation number of +1. If there's 2 of them, that makes +2. Well, the only number -8 that's going to be 0 is +8. Well, I already have 2, so I need +6. 2 + 6 is 8, -8, 0. Since there's only one sulfur, the S is also its, the 6 is also its oxidation number. So +1, +6, and -2 are your answers there. We're going to end up with the same kind of a situation here. If you look up silver on your colorful sheet, you'll see it's +1. You look up O on your colorful sheet, you'll see it's -2. All right, now chromium, which is Cr, has a couple different possibilities. Actually, more than a couple, 1.5 couples. It has 3 possibilities: +2, +3, or +6. All right, well, the silver only has one choice, +1. O has -2. So multiplied by 2 here, I'm going to get a total charge of +2. -2 times 4 is -8. Again, goal to add up to 0. I need +6, right? 2 + 6 is 8, -8, 0. Since there's only one chromium, the oxidation number has to be +6. All right, we're going to end up with a different scenario here. K2CO3, this is potassium carbonate. Looking up potassium on your colorful sheet, you'll get a +1. O, you're going to get -2. And carbon, I have it in as -4, but it can actually be from -4 all the way to +4. Here's what I do know. In a battle of negativity, O beats everything except fluorine. So O is going to stay -2. Times 3 is going to give us a total charge of -6. The oxidation number of potassium is +1. Times 2 is going to be +2. If I need to get 0, I have to have a total charge on the bottom of 6, because 6 - 6 is 0. Well, I already have +2. I need to get +4, right? 2 + 4 is 6. -6 is 0, so the carbon is a +4 there. Zirconium chloride. All right, well, if you look up zirconium, you're going to find it says +4. If you look up chloride, you're going to find it's -1. This one's pretty easy. That's actually the answer. Positive and negative, you're done, right? This adds up to be -4. This adds up to be +4, and you're at 0. Oxidation number is +4 and -1. Okay, here, this is bleach, by the way. Sodium hypochlorite. Looking them up on your colorful sheet. +1, -1, -2. Now, there is no battle for positivity. There is a battle for negativity, though, right? And what's going to happen, this is fine at +1. O versus Cl. Now, chlorine is a highly electronegative element, but not as much as oxygen. So O keeps the -2. And what you're going to find out is the chlorine actually has to change and become +1, right? Which, coincidentally, this is also their total charges because there's only one of each element. All right. Now, I want to go over one more polyatomic ion, and then I'm going to give you a couple more difficult ones to try just to see if you can get through them, okay? So let's do something like this, okay? Let's do NH4 plus, which is ammonium, and let's do MnO4 minus, which is the permanganate ion. Okay. Now, the difference between these and what we were just doing, I know we touched on it in the last lesson, but if you noticed, all the previous 5, they all added up to 0, right? Okay, well here, you're not going to add up to 0. You're going to add up to whatever the charge of the ion is. This is really like +1 and -1, right? They just don't write it in. Okay, so here, instead of adding up to a total charge of 0, you want to add up to a total charge of +1. Well, let's look up our charges on the colorful sheet. If you look up nitrogen on your colorful sheet, you're going to find it's -3. And if you look up hydrogen on your colorful sheet, you're going to find that it's +1. Okay. Well, that's actually good because positives and negatives, there's not really a battle. All right, so +1 times 4 adds up to +4. -3, there's only one nitrogen, so that's a -3. Look at that. -3 and +4 adds up to an overall charge of +1. Okay, so that's good. That's why NH4 has a charge of +1. Okay, now the MnO4, the permanganate ion, adds up to a charge of -1. Well, manganese, which is a transition element, has a few different charges. All of them are positive, though. So oxygen is going to end up being the -2. Okay, so -2 times 4 is going to give me a total charge of -8. The overall charge is -1, so I need to add up to -1, right? Okay, well, there's only one number, -8, that's going to give me -1. That number is +7, okay? So the oxidation number of manganese there is +7, okay? All right, so I'm going to list a few more of them to try, and then we'll see if you can figure them out. How about a little AgNO3? That's silver nitrate. I'll make that number 1. How about PO4 3-? That's the phosphate ion. Number 3, how about we do C3H6. Number 4, we can do the dichromate ion, Cr2O7 with a 2 negative charge. And number 5, let's do, how about WCl6, okay? So I would like you to try to write the oxidation number for each element. So we got AgNO3, PO4 with a 3- charge, C3H6, this would be propene, dichromate ion, Cr2O7 2-, and number 5 is WCl6. Remember, the oxidation numbers, I write them on top. So like that's the oxidation number, right? The oxidation number is the charge of just one atom. This down here, these are my total charges. But these are your answers. Your oxidation numbers are your answers. All right? We're going to talk about oxidation and reduction next week's lesson. All right? Hope you're all well, and try not to miss me too much. See ya.